You can use the leading coefficient test to determine the end behavior of a polynomial. So what does that mean? Well, consider this polynomial right here. F of x equals negative 2x squared plus 5x minus 1. Without even graphing this polynomial, it's possible to know whether the graph goes up or down as you go further and further to the right on the graph, and whether it goes up or down as you go further and further to the left. And the way we do that is with the leading coefficient test. So here's the idea behind that test. First, just identify the term in the polynomial with the highest power. So that would be this term, negative 2x squared. So this 2 is the highest power or the highest exponent of all the terms. Next, you just need to look at what is the coefficient on this term. Well, that's just the number out front here, negative 2. Based on whether or not this coefficient is negative or positive, and based on whether or not this power is odd or even, you can know if the graph is going up or down. So here we have an even power, and here we have a negative exponent. So I've written this 4x4 grid up here to kind of summarize how a graph behaves depending on the coefficient and the power. So in our case, we have an even power, so let's circle that, even power. And we have a negative coefficient, this negative 2, so let's circle that. And now let's find where they intersect in this quadrant, so that would be right here. So this tells us that the polynomial goes down to the left and down to the right. Now, if you actually were to graph this polynomial, it would look something like this, where as you get further and further to the right, the graph is indeed going down, or it's decreasing. And as you get further and further to the left, the graph is also decreasing or going down. Now, the reason that this leading coefficient test actually works is because the term in the polynomial with the highest power, so like 2 in this case, it's the most influential in determining whether the graph is actually going to go up or down. So you can imagine, like, if x is equal to 10, if you plug in a 10 right here, you get 10 squared is 100 minus 2 is negative 200. If you plug in a 10 right here, you get 10 times 5, which is 50, and then this is just minus 1. So this term holds the most weight, or it's always going to be the largest value that influences the graph. And you can imagine if we plug in even larger values of x, so like 100, this would be 100 squared times negative 2, which would produce an even larger value compared to these other values. So let's take a look at a few more examples of how we can use the leading coefficient test. All right, let's say we have this polynomial right here, and we want to know the end behavior of the polynomial. So first, let's identify the term with the highest power. So that would be this one right here. It has a power of 5, and that is an odd number. So let's circle odd on our grid up here. And then the coefficient is a 4, so that's a positive number. So let's circle the positive number. In the place where these two intersect, it says the graph should be going down to the left and up to the right. So that's our answer. Now, if you were to graph this, you would find that it looks something like this, where it does indeed go, as you get further to the right, it is going up to the right, and as you get further to the left, it is going down to the left. All right, let's try this one. We have f of x is equal to negative 3x cubed plus 2. So let's identify the term with the highest exponent. That would be this one right here. It has an exponent of 3. So that's an odd power. So let's circle odd power. And then we see that the coefficient out front is a negative 3, so a negative coefficient. So this tells us that the graph will go up to the left as we go more and more left, and down to the right. So that's our final answer. Now, if we were to graph this, we would find that it looks something like this, where indeed as we get further and further to the left, we are going up, and as we get further and further to the right, we are going down. All right, let's try one more example. Let's say we have this polynomial, f of x is equal to x squared plus x minus 10. So first, let's identify the term with the highest power. That'd be this term right here. So it has a power of 2. So that's an even number. So we'll circle even power. And then it has a positive coefficient. So if we want, we can imagine that there's just a 1 right here, which is a positive number. So we'll circle positive coefficient. And this grid tells us that this graph will go up to the left and up to the right. So that's our final answer. And if you were to graph this polynomial, you would find that it looks something like this, where indeed as you get further and further to the right, it is increasing, and as you get further and further to the left, it's also increasing, or it's also going up. So you can use this little 4x4 grid right here to determine the end behavior of any polynomial using the leading coefficient test.